Good morning, everybody. Today I'll start the topic hydrocyclone offshore disposal system and a few numerical problems. So how to solve it, how to design or how to size the offshore disposal, how to size this skimmer for vertical, horizontal, for rectangular cross section. Now, in previous lectures we have seen that there will be horizontal skimmer, vertical skimmer, and some skimmer can have rectangular cross section. Okay. Now, after a skimmer, you got the fluid which should be disposed further. But if you have offshore structure, so there will be disposal technique different. If you have onshore system, the disposal system will be different. Offshore actually you will be having long pile structure or caisson structure, there you are disposing. Now there will be hydrocyclone in some steps. So what is hydrocyclone, how it is working, we will explain. So hydrocyclone is called an enhanced gravity separator. So using gravity separator, you have seen this static system, and because of density difference or gravity difference, fluid is moving upward or downward. Maybe water will be downward and oil will be upward. But when you are using hydrocyclone, so it will be using a specific technique which will be enhancing the separation rate. So how does it work? So normally it will have one cylindrical section and it will have one inlet section here and one exit section here. Okay, and I'll draw like this so that you can understand easily. Okay, I'll remove this one. Okay, so this is called hydrocyclone. Okay, so this is hydrocyclone. Okay, so hydrocyclone will have one inlet port, one exit port for oil exit, and water exit. So this is one cylindrical section and it is having one mixing section. Also you are creating lots of vortex or vortices inside the system, and that will be separating oil and gas. How it is working? Let's say top inlet section, if I take top view, it will be looking like this. Okay, one hole is here, another hole is here. I'll make like this. Okay, no, it's not looking like this. Okay, from top view if I take from here, so it will look like this. Okay, this is central hole, this is oil exit path, this is oil exit if I am looking at from top. Okay, and it is your inlet. Okay, and fluid is entering tangentially, so tangential entry. So fluid entry tangential. Okay, so it will be touching the surface and it will be entering, so it will be rotating actually. Okay, so tangential entry, so because of high velocity it will be rotating, and normally pressure will be requiring 100 psi. Okay, if it is having lower than 100 upstream pressure upstream of this system, then you have to use one pump, so you need extra energy to increase the pressure. Okay, so if we don't have pressure, that fluid will not come into very high velocity. We need very high velocity to create. Okay, and it will be working well with more than 20 microns oil droplet size. If you have less than 20 microns, it will be difficult to separate. Okay, so it will be like 10 to 20, you can say. I will write 10 to 20, more than 10 microns. Okay, rejection rate, the two definitions are here. Rejection reject fluid rate divided by total inlet fluid rate, and pressure drop ratio PDR equals delta P between inlet and reject. Okay, and del P inlet to water outlet. So inlet means here. Okay, and water outlet is here, this ratio. So let us say P1, P2, P3. Okay, so inlet to outlet pressure ratio will be like P1, P2, Okay, del P between inlet to reject. Inlet means P1 divided by P3. Okay, this ratio is called pressure drop ratio, and reject ratio is the reject fluid by total fluid inlet fluid rate. So, reject ratio is P3 by P total inlet fluid P1. Okay. So, reject ratio normally it will be 1 to 3%. Okay, very small amount of oil will be there. So, that is why reject ratio will be 1 to 3%. Okay, and reject ratio proportional to PDR. Okay. So, you should remember this small relationship, because when if I give objective questions, so this will be very important factor. Okay. Hydrocyclones are excellent coalescing device, primarily treating device, followed by downstream skim vessel. So, what happens upstream, you have 2-phase 3-phase separator, heater, then you are putting on hydrocyclone, then you have skimmer tank. Okay. It is not the last one. Okay. So, upstream separators, hydrocyclone, you are removing oil content further, then you are sending to skimmer, then you are disposing. Okay. So, followed by downstream skim vessel. Advantage, no moving part. You can see there is no moving part actually. If I have sufficient pressure, if I let us say 100 psi pressure is already here, so I do not need any extra pump. So, there is no moving element. So, I already explained you that in engineering system, if I have relative moving element, then life will be lower. So, in that case, we do not have any relative moving element. It is just fluid is flowing. The machine is not moving, right? There is no part inlet or exit or anything is not moving. So, life will be longer. Okay. But if you have any pump, then pump life will be coming into picture. Okay. So, if you have more than 100 psi pressure, they will be cheaper actually, and you do not need any extra pumping mechanism. So, it is very simple system. But if you have pressure lower, then in that case you have to increase pressure with a pump. So, that will be costing, okay, and it will be reducing reliability also. Okay. So, insensitive to motion modular design. Okay. Insensitive motion means offshore situation, let us say where waves and tides are there, because of that the system offshore platform will be moving actually. Okay. When it is moving, little bit motions is there. So, this system is insensitive to motion. So, it will be working well in offshore applications. Okay. Onshore also you can apply, there is no issue. Offshore also you can use. Modular design, lower operating cost if inlet pressure is available. Okay, operating cost will be lower because there is no investment actually. You just want design done. But if you, this cost will be increasing if you use more pumping system. Then pumping means electrical consumption will be there, pump life will be there 2-3 years, 4 years, right? So, that will be costing money. So, disadvantages, if pump is required, then cost will be increasing, and sand issue. Sand means fluid is flowing at very high velocity. So, at high velocity, you can remember high velocity erosion rate will be higher. Okay. Erosion rate higher means your life will be lower, system life. Okay. So, if you have lower sand, it is better. If larger amount of sand is there, then you have to check whether erosion is happening or not. If erosion happening, then maybe you have to replace the system frequently. Typically, one well bore will be producing about 30 years. Okay. So, the figure, and hydrocyclone should be placed vertically actually. Okay. I will draw again this one like this. So, it will be like this, and there will be one almost flat section, then this is cylinder, you can see upper one, right, and then one conical section must be there, then fluid is entering tangentially, I told you, fine, and this is your exit. This is water out actually. Okay. This is oil out. Oil is going from top, and how it is working I will explain. Entry. Okay. And fluid will be entering, I already told that, tangential entry. Okay. So, it is rotating, right. So, rotating, and what will happen, fluid is rotating, and because of gravitational force it will be going down also. Okay. It is rotating and moving down, like toilet flush chamber is rotating and going down, right. So, here also rotation, it will be going down. Then what is happening? Then why oil is also not going down? So, what is happening? At very high velocity, water particle will try to touch the external surface, okay, because density higher, mv square formula, you can see centripetal force, right, you can remember the school books. So, that centripetal force, because of that centrifugal force, water will be touching the outer surface and oil will try to touch, but it will not get space because water will take the space, because oil lighter density. So, oil will try, but it will not go. So, oil will be rotating at the center. Okay. So, oil will be rotating at the center actually. Okay. Now, you got separated oil and water inside the system. Now, you put this pipe, long pipe from top and suck the fluid. Okay. So, water you are getting from top and oil oil you are getting from top, water you are getting from bottom, and this is entry. Okay. This is using based on your centrifugal force. So, and it is assisted by gravity, right? When it is rotating, it is going down also, because of gravity it is going down. So, which is going down? High density fluid. If you have sand, sand also will go down. So, if you have two fluid, maybe solid and fluid, two phase or single phase or multi component fluid, and density difference is there, rotate at very high velocity. So, high density fluid will be trying to create larger radius, lower density fluid will try, but high density will take the space, largest space, lower will be rotating at the center area. You suck that lower fluid separately. Okay. So, oil water you got separated like this. Okay. So, this way hydrocyclone will work. Fine. This is hydrocyclone principle. Okay. So, the terms they are using here, we should remember also. This is entry means oily water. Oil plus water, small amount of water, maybe 2000 milligram per liter, right? And out maybe 800 milligram per liter, because amount of what oil reduced of oil in water, of oil in water. Okay. And tangential entry is tangential. Okay. And oil rejection, this is oil rejection, they say. Oil rejection. Okay. Cylindrical salt chamber, this is salt chamber, this section, cylindrical swirl chamber, because it is swirling, continuously rotating. Okay. This is cylindrical swirl chamber, and some conical section may be there, fine tapered section, this is tapered or conical. Okay. And this is cylindrical tail section, this is tail section. Okay. Tail. Okay. Downstream outlet, this water outlet, outlet, outlet. Okay. So, this is actually clean water, clean, or can say cleaner water. Okay. Because we are not removing 100%, so some still traces will be there, that's why they are saying like clean, I can say cleaner, this is better term. Okay. Okay. Now, if you have low pressure, let us say 100 psi pressure is required, I said. Okay. Now, you want to increase pressure. So, what type of pump you will be using? So, pump, there will be several types of pumps, I will discuss later. So, one type of pump called progressive cavity pump. Progressive cavity pump. So, what is progressive cavity pump? Actually, it is single screw pump. If you want to know details about this one, so you can follow my lecture on artificial lift NPTEL lecture. I have already recorded, the video will be available to you. Okay. So, there will be progressive cavity pump, I explained in details around 2.5 hours, 3 hours. So, it is actually single screw pump, it is called no shear pump. Why no shear pump? This is positive displacement, no shear pump, positive displacement type. Okay, it is for positive displacement type, no shear pump. The shearing, what is this issue of shearing? Shearing is like centrifugal pump you have. Centrifugal pump will be rotating at very high velocity. When it is rotating high velocity, the oil particle, what, let's say I have 500 micron size oil particle. So, because of high velocity and huge turbulence inside pump, the particle will be broken. When particle broken, it is creating too small particle. So, separation from any device will be difficult, because your main purpose is to increase particle size. But very high velocity pump like centrifugal pump, it will be giving shearing action because of high turbulence. So, particle will be broken, it will create very tiny particle. So, tiny particle, again your separation life will be difficult. Okay. So, in that case you use progressive cavity pump. Progressive cavity pump, what does it do? The function of PCP is like this, it will take certain amount of fluid, and because of pump rotation, that fluid will be transferred slowly. Okay. So, it will not disturb the flow, whatever captured flow is there, it will not disturb, it will take flow and it will move. Okay. Like our heart working, this is also one pump actually. This is the oldest pump you can say, and longest duration of survival of the pump, right. In Japan, if you see Ikigai, if you read the book, 120 years common people living there. So, their heart is working for 120-30 years, right. So, there is the longest duration, longest serving pump. So, in that case also it will take certain amount of fluid, again it will deliver. Okay. When it is like beating, it will take certain fluid, it will be delivered. So, it is not shearing. If it is shearing, then your RBC or WBC will be broken, so you will not survive. Okay. Similar way, this PCP also, it will take certain amount of fluid, it will deliver. It is not pulse, it is not pulse in the that sense like this. It will be rotating, so that is also creating small pulses, but it takes small fluid, transfer, so it will be delivering like this. Okay. So, details you can go through my lecture. There will be lots of YouTube videos also, if maybe you can go through it. So, that shearing pump, non-shearing pump actually. So, particle will not get sheared, it will not create smaller particle. Whatever particle size there, same particle will be there, but you are increasing pressure. Okay. So, PCP you can use, single screw pump, or other type pump also will be there, maybe you can use, but they have given example progressive cavity pump. And I'm stressing here also because I have already recorded lecture in YouTube, so you can look at it. Okay. Okay. So, this hydrocyclone, it is having disadvantage. They have no moving part, I already told. Okay, moving part is there, this problem. So, there is no moving part here. So, minimum maintenance and operation possible. Then their compact design reduces weight and space requirement. So, it is very compact design. Okay. It is just giving rotation. For example, if you say flotation chamber, dissolved gas or dispersed gas, whatever. So, they will take larger space, but in hydrocyclone system, if you see, it is very smaller actually, very compact. Okay. So, it will not take lots of deck space. Okay. So, those can be used for offshore application, which is not taking space, because offshore space is one problem, because you have small platform, you have to put everything. Okay. Their engineers will be working, so their food and all the arrangement must be there, oil separation system. So, everything will be there on single platform. So, their space constraint is one issue there. Okay. So, their hydrocyclone you can use safely, because space, very small space is required. Okay. They are insensitive to motion, so it will be suitable for offshore application, like say shaking of offshore platform because of the wave and wind. So, it is fine. Okay, because high velocity fluid is moving and it is separating. They are insensitive motion. They are modular design, so you can use one separator, two separator, three separator, and very simple design you can see. Only cylindrical section is there, inlet and outlet is there. So, it is very cheaper also, modular design possible, and they offer lower operating cost if you have higher pressure. If you have lower pressure than 100 psi, then most probably you will be requiring one pump. Again, any pump you should not use, rather you should use non-shearing pump. Okay. One example is progressive cavity pump or single screw pump. So, there will be multiple screw pump also they can use, but they have given example PCP. So, just you should remember. Okay. And disadvantage, this is basically disadvantage, that one, if pressure is low, then you need extra energy to pump it. Okay. So, that is the basic disadvantage. And another sand. So, disadvantage is that advantages. disadvantages like pump required and sand is one issue. Okay. So, basically two disadvantages they have reported, others are very nice. I mean there is no moving element and there is no electrical requirement actually. So, it is very simple system. Okay. Now, we will go to offshore disposal system. So, offshore disposal system it will have it will have certain equipment. So, produced water should not be dumped directly into the sea after treatment. Okay, there are environmental regulations all the companies must follow. If someone is not following, it will be their problem. Okay, rainwater equipment washed down, water needs to be disposed of. Okay, so some produced water you are disposing, and rainwater and other thing also, like you have big flotation unit and other unit. So, heavy rain is there, so rain will be entering actually in a flotation chamber others. So, you have to handle that one also, and many platforms they will have their own oily water production also, that also they must dispose. So, they should have certain equipment which will be used for all type of disposal things. Okay. A disposal device dispose the water deep enough below the sea surface and away from the wave action. Wave action means like if you see ocean surface, okay, ocean surface and ocean seabed, and this is ocean surface or ocean surface I can write. I will write ocean surface. Okay. So, what happens ocean surface there will be wave, okay, tidal wave will be there, tidal variation of water, and there will be local waves per second, per minute few waves will be coming. If you go to any local sea beaches, you will see these waves are coming, right. So, and wave effect will be around 20 meter or something. Okay. So, your disposal pile or pipe will be coming below the wave action. Okay. And what happens during wave actually particle will be rotating like this. If you see actually mid ocean wave particles are not moving actually. In nearby coast if you go, water coming to you, so particle moving there, but if you go deeper water, so their particle are not moving, particle will be just rotating in local areas. Okay. When it is rotating in local area and if you are disposing, let us say in this area, okay, so what will happen, this water will be mixed up again and again. So, they want to avoid that one, so there will be longer pipe and they will be disposing. Okay. And your platform will be working here and some pipe will be coming like this longer. Okay. This is called disposal pile. Common device disposal pile are skim pile, SP, special type of pile actually serpentine pipe. So, some company has given the name SP pile.